Sentry stands alone in enabling developers to identify and resolve application issues faster than ever. Unlike other tools, Sentry is designed specifically for developers, providing quick access to the platform, along with comprehensive details, context, and clear next steps for effective problem resolution. And getting started with Sentry is just an installation and a few lines of code away. Simply choose from our listing of over 100 supported platforms, configure your DSN key, and you will gain access to a myriad of monitors, including errors, sessions, transactions, and profiling, to name a few. I will be walking us through an iOS e-commerce application today. We take care of a lot of the heavy lifting via the Sentry wizard, which can be accessed via Homebrew by running brew install and then the wizard itself. This will install the Sentry SDK into your iOS application and initialize it accordingly with the DSN key assigned to the project. With Sentry ready to go on my iOS application, let's walk through the developer's workflow. We have a simple shop setup experiencing critical issues, leading to end-user impact. Sentry will help us see what's up with the application and solve for the user impact with only a handful of clicks in a matter of minutes. Once the root cause is identified, we can take it a step further to solve for performance bottlenecks and find opportunities for optimization. So let's dive in. As a user, I may want to buy some pricey plans, but when I start the application, I'm left hanging for a while, which is a prime opportunity to ditch this app and shop at a competitor. There's no direct way to tell what's going on with the slowness, as this could stem from the user experience or backend or network. As a user, we just don't know. Furthermore, after giving this app a chance to purchase hundreds of dollars of plants, we're encountering some errors because, well, nothing's happening, leading to a loss in customers and therefore a loss in dollars, which is not good. But a developer with Sentry is never left in the dark. In real time, the developer receives an issue alert correlated to this plant enthusiast's subpar experience. Additionally, performance alerts have come in to notify us there's a problem that might contribute to the initial slowdown. Let's figure out the broken checkout flow first, and then we'll investigate the products page slowness later. We see there's an alert for an insufficient inventory that has a significant impact to our user base. We haven't even accessed our org, and there's a plethora of details to observe and actions to take. For example, we can supplement this alert to auto-generate a Jira ticket for the issue when it fires. Looks like this issue was flagged as high priority, so this should be our starting point. Let's give it a click. We can see here the error, its message, and again, the impact to the user base, as well as the total occurrences of this issue. These key value pairs known as tags are very helpful with triaging and debugging, as well as a screenshot from the moment the error had happened. These details help with debugging, but we also at Sentry provide guidance. With our GitHub integration, we're able to show which commit may have been the source of this bug, and the symbolicated stack trace will tell us where the error occurred from our code. So in this case, we can see that this code has not been unit tested, and that we should probably write a test alongside resolving this to ensure that we don't regress here again. We can also hop directly into GitHub or CodeCov from this stack trace. Furthermore, the code responsible for this issue seems to be uncovered by testing, as denoted by the red here. As we get to fixing bugs and expanding our codebase, we'll increase test coverage to catch this in pre-production and avoid future regressions thanks to our CodeCov integration. Breadcrumbs provide a timeline of activity and subsequent invocations leading up to the error itself. The data that we've reviewed can also be leveraged with AI, and this will give us guidance from Sentry on how to fix or debug this issue. Sentry AI tells us the crash is likely on our inventory check method, which points to something server-side. This is a good start to better pinpoint what needs revision, and the AI suggestion shares some docs and next steps. Alongside context and details about the user, app, and device, we can also render JSON representation of the view hierarchy of the error. Any additional context specific to your app can be added as tags, breadcrumbs, additional context, or added as attachments. Now that we've determined the next steps for this broken checkout flow, let's get the proper folks involved and aligned. As part of the GitHub integration, suggested assignees are presented thanks to Sentry's code owners integration. Now the issue can get assigned to the right developer to resolve. And with that, we have strong evidence that this issue stems from the backend. With the correlated trace, Sentry links errors across the front-end and back-end services, so we can hop to the back-end with a single click. Much like before, we can review these issue details and provide more than relevant insight to the back-end engineers associated with the service. So now that this critical issue is on the road to mitigation, let's return to Slack and see what other opportunities Sentry shared with us. Looks like Sentry is identifying file I/O operations on the main thread, contributing to slowness when loading crucial assets. Rather than simply sharing this insight, Sentry aims to describe why slowness is happening and what next steps to take. Let's dive into this. Sentry generates this performance issue based on the span data. We can see here the problematic spans are denoted. Let's head to the transaction to see what's happening in the larger picture. There's our performance issue. We'll move this throughput to a background thread to optimize app launch and prevent app hangs. But I can see another contribution to slowness. This iterator takes quite a lot of time, about 3 seconds. This is an excellent opportunity to optimize. Another layer deeper, we can leverage the profile of this span to solve for performance setbacks such as recursion. The profile gives us a flame graph of function level details from the main thread. We can modify the color coding to provide us with that heat map of profiles with different perspectives. It looks like the getIterator function is recursing excessively, which needs to be addressed. With profiling, the developer can find exactly where and why the slowdowns are happening, from the screen load details all the way to its function calls. We can also understand performance slowdowns by investigating patterns that Sentry surfaces, made available in the transaction summary. Sentry shows us which spans, tags, and functions are the likely culprits. To better understand screen load times, we can also use the screen loads page. We can identify slow or regressed screens and understand the factors contributing to slow time to initial display and time to full display. There's a notable difference in these metrics, as we can see between our 2 latest releases. The screen summary has a series of widgets that show data from 2 select releases side by side. Between our releases, the anomaly comes from a UI load screen operation, accounting for that duration difference. We can investigate by finding occurrences of that span and drilling into samples, giving us a set of data that we can look at from the transaction or profiling perspective like before. We can also gain similar insight via our App Starts module, where we surface any notable deltas between 2 releases to investigate and mitigate any spans contributing to a poor startup experience. So, in just a few clicks and a handful of minutes, we were able to get notified and see what was not so right with our application, solve for those anomalies, and then learn from the occurrence without having to dig or ask questions. We received real-time alerts for error and performance setbacks, drilled into the root cause from front-end to back-end, notified and then assigned to the proper folks. Then, we looked at the slowness plaguing our customers to locate a performance issue we handled with profiling. Lastly, we took a proactive approach by inspecting our app's time to initial and full displays to find new areas to refactor and optimize. This is how iOS developers can see and solve their issues within minutes. Sentry informs the developers of code-level issues and gives them their data in an aggregated, structured, and opinionated way to optimize time to resolution and improve the integrity of your applications.